So, all right, so how do you solve this thing? Secant of theta is negative 19, tangent of theta is greater than 0. First thing you got to determine is what? Where it's at. Yeah, what quadrant? Which quadrant is that thing in? How do we determine that? So let's do the little, here, I'm going to change the color here. So we got to do the all students take calculus thing, right? So all students take calculus. So what's it telling me about tangent? Tangent theta greater than 0, what does that mean? Positive, right? Greater than 0 is positive. This is tangent's positive. So which quadrant are you thinking right away? It's either 3 or 1, right? Because they're all the trig functions are positive in quadrant 1. And tangent and his upside down, cotan, are positive in quadrant 3. The other 4 are negative, right? So it's 1 or 3 right away because they say tangent's positive. And then now, could it be all? Could it be all or positive? No, because secant's negative. So they're not all positive. So it's not quadrant 1. So it's clearly quadrant 3. You with me? So we know we're in quadrant 3. All right. So with that in mind, let's draw ourselves a little triangle in quadrant. Now, if I drew my triangle like this, that would be a bad triangle. Why is that? Why am I calling that? It's a moral issue. It's a bad triangle. Why is that a bad triangle?
You always have to reference to the x-axis.
Excellent. Right? You got to hit the x-axis, not the y. Everybody catching that? That's wrong. Don't do it that way. You're hitting the y-axis. No, no, no. You want to hit the x. Remember, the angles are always with the x. I haven't really given you good reason for that yet, but we will. You got to go like this. You got to hit the x-axis. Whoops. And that's a bad triangle too. Why is that one bad? I'm doing a lot of bad triangles today. Why's that one bad? That hits the x-axis. It's supposed to come the origin. It's supposed to come out of the origin, not have a right angle there, right? It's supposed to come out of the origin. So I'm doing everything wrong here. So like that. And the right angle is supposed to hit the x-axis. So you with me on that? That makes sense. So I don't want you to get messed up doing the wrong triangle. It's probably good that I did that wrong. So is that good? Everybody seeing that? So the point that, the line's got to come out of the origin, and it's got to make a right angle on the x-axis. We're always having our triangles make a right angle on the x-axis, not the y. And it comes out of the origin. All right, so there's my triangle in the third quadrant, the tangent quadrant down here. Now, it says that, so remember the whole SOHCAHTOA thing, that's our main guide here. You do get a 3x5 card, on the exam, both sides, I said, so you can write that on there. So, all right, secant of theta is minus 19. You probably also are going to want to write on your 3x5 card that sine is, upside down of, or, you're probably going to want to write sine, cosine, tangent, and then upside down, 1 over sine, 1 over cosine, 1 over tangent is what? Cosecant, secant, and cotan, right? Like that. Probably a good idea just to have those clearly on your paper. So you know cosecant is upside down of sine, secant is upside down of cosine, cotan is upside down of tan, right? So when I look at secant, I think secant, oh, that's upside down of cosine. So if the secant is minus 19, then the cosine is 1 over 19, and still negative. You're with me, right? Because secant is upside down of cosine. So if they give me a fact about one of these 3 trig functions on the right, cosecant, secant, or cotan, I'm just going to turn it into something involving sine, cosine, or tangent, because that's easier for me. Is that good? So secant is negative 19. That means cosine is negative 1/19. You just flip it, don't you? Okay, now so what? Well, cosine is adjacent. Now I've got cosine, so now I can use the ka, because that's about cosine, right? What is cosine? Where do I put the angle? Do I put it here? No, again, the angle has got to be to the x-axis. Right there. See, that's from the x-axis. Right? Okay. So cosine is adjacent over, so it's negative 1 over 19. It's adjacent over hypotenuse. Oops, let me get this out of the way here. So, right? You guys with me on that? It says right here, cosine is adjacent over hypotenuse. So cosine, negative 1/19, is adjacent over hypotenuse. So, how am I going to do that? Well, the cosine of theta, which we have the 3 sides. We have this side, which is his adjacent side. This is the hypotenuse side, and this is the opposite side from that angle theta, isn't it? You with me on that? Right? Here's angle theta. These two sides hit angle theta. So they're his neighbors. They're next to him. They're not opposite. But this one's the hypotenuse. It's across from the right angle. So this is called the adjacent side. And then this is the opposite side. So when we say adjacent over hypotenuse, 1 over 19, we go, oh, okay, so you're saying this is negative 1, and the hypotenuse is 19. Yeah, that's what they're saying. Okay, yeah, couple things. Good question. What about those negatives? How do you know whether to put the negative, right? This negative that's on the fraction there. Should that, what do you do with that negative? Let's be real clear with that. Let me say a couple things. When you have a negative on a fraction, like negative 119, does that mean it goes on the top, or does it go on the bottom, or does it go on both?
It depends.
Can it go on both? Why can it no way go on both?
I have hypotenuse can't positive.
What's two negatives?
Positive.
Ain't that? You with me? It can't go on both. So you guys clear on that. We gotta be crystal clear throughout the rest of your math career. When you have a negative on a fraction, you can put it on the top only, that's fine. Or you can put it on the bottom only, that's actually fine as well. But you may not put it on both, because two negatives is positive. It's no longer negative. Right? We good? So you're going to make one of the two of those guys negative. Technically, it doesn't matter which one. Well, it's easier to just, just look at this graph, right? This is back and down. Back. So this is negative. Right? Now, remember I said if you want to just ignore, it might be easier. I remember my own daughters, when I helped them with Trig, it was easier for them to just ignore all the signs. Just say, yeah, who cares? They'd always say, Dad, I don't care about that. I'm just going to put a 1 there and a 19 there. And I'm just going to work out the numbers, and I'll fix the signs later. You could totally do that. Probably easier. How do you fix the signs later? The all students take calculus thing. Right? We know this is the, right? All students take. We're in the T quadrant. So we know who's going to be positive in the end. Tangent, and his upside down, cotangent, and the other 4 are negative. So if you want, you can just ignore the signs, and then at the end, just make tangent and cotangent negative, and the other, positive, and the other 4 negative. And that's true. Or you could say, well, that's a -1, and it'll all work out that way too. Either way. So why don't I just ignore the signs? I'll just put a 1 there, 19 here. All right, that good? It's technically a -1, but who cares? I can fix it. What is the other side over here? I need this side. How do I find that side over there? Yeah, it's Pythagorean time, right? Pythagorean time. So let's come on up and do the Pythagorean thing. So, here we go. Pythagorean, just call this, whatever you want to call it. Call it y, because it's up and down. Call it x, call it Joe, whatever. 1 squared plus y squared is, or I guess maybe b, whatever you want to call it. It doesn't really matter. A squared b, yeah, probably makes more sense. You're used to seeing b. I'll just call it b. Whatever, it doesn't matter. So, good there? I'm doing the Pythagorean theorem, right? A squared plus b squared is c squared. When you do the Pythagorean theorem, the order on the A and the B doesn't matter. Excuse me. But, excuse me again. Okay. But you got to get the C alone, right? The C has got to be the side across from the right angle of hypotenuse. That's got to be the one that's alone. The order on the other two doesn't matter. What's 19 squared? 381? 361? 361, that is? Okay, thanks. 1 squared is 1. Got to solve for B there. How do we solve for B? -1 from both sides. B squared is 360, and then square root it, right? Square root it. Is that what it is? Yeah. So if you, do you know how to? So some of your calculators do it automatically, and that's great. If not, let me help. You could say 36 times 10, right? You just use your calculator. Just start dividing by numbers. You can break it down any which way you want. 36 times 10, and 36 is 6 times 6. Or right away you see the 36 and you go, oh, that's square. So square root of 36 is 6. And then the 10 is left inside, right? You with me on that? You okay with simplifying that? Everybody good to there so far? So that means this b over here, this b is 6 root 10. So everybody see where we're almost there now. Everybody see what we've done so far. We just started with the tangent of theta is positive and the secant is negative. That helped us know we were in the third quadrant. And then we said, okay, they said secant is negative 19, which means cosine is 1 over 19. We had that here. And then that was cosine is adjacent over hypotenuse, so we made the adjacent 1, the hypotenuse 19. Did the Pythagorean theorem to find the other side. Now we can find all 6 of the trig functions, which is what they're asking us to do. Let's find all the trig functions. So I'm kind of running out of room here. Let me squeeze it in over here. So to find the 6 trig functions, we'll just go through them one at a time. Here we go. Sine is, like it says up here, opposite over hypotenuse, right? So what's the sine going to be? From theta, it's always from theta's perspective. Who's the opposite from theta?
6 root 10.
Yeah, opposite. 6 root 10 over the hypotenuse, 19. Oh, yeah, I'll fix the signs later. How about I just get all the answers first, and then I'll get the signs later. That'll work fine. So there's the sine of theta, but you're right, it is going to be negative. So there's the sine of theta. What's the cosine of theta? I really should have said sine of theta. I'm just running out of room. What's the cosine of theta? Well, actually, they give me, I know that one. Cosine is adjacent over hypotenuse, so adjacent, 1 over 6 root 10. That's not the hypotenuse. 19. But, and I'll fix the signs later. Tangent of theta, TOA, opposite over adjacent, so opposite, 6 root 10 over 1, the adjacent. So that's just 6 root 10. That good? Now, let's do the signs like you all were saying. We're in the third quadrant. We're in the T. All students, right? All students take calculus, so we're in the T quadrant. What does that mean? Tangent, only tangent and his upside down, cotangent, his reciprocal, are positive. The other 4 are negative. So only tangent is positive. The other 4, so sine is negative, cosine is negative. You with me? And then they want the upside downs. I'm totally running out of room. Come over here now. Do the upside downs. So the upside down of sine, take this answer here, bring it over here. So cosecant of theta, which is upside down to sine, just flip it upside down. 19 over 6 root 10, and it's still negative. When you flip it, you keep whatever sign. You're just flipping. You're not changing the sign. So sine was negative. So cosecant is also negative. It's just flipped upside down, right? We can't leave that root on the bottom, though, right? You all know that. So we gotta get rid of that root. So what do? Multiply top and bottom by the root. Remember that from your algebra days. So then what do we get? That's minus 19 root 10. What's the bottom? Yeah, is everybody okay with that? Root 10 is root of 100, which is plain 10. So it's 6 times 10, 60. That too quick? That okay? On that? See what happened on the bottom there? So I got to find the other 3, right? I've got sine, cosine, and tangent. Now I got to flip it to find the other 3. They want me to find all 6. So I flip sine, flip it upside down, and you keep the sign. You can't have a root in the bottom, so you multiply top and bottom by root 10 in the bottom. Root 10 is root of 100. Root of 100 is 10 times 6 is 60. Right? 2 roots that match make a regular 10, don't they? Root 10 makes regular 10 times 6 makes the 60, doesn't it? That's another way to think of it. Right? Root 10 is plain 10. Right? When you have 2 of the same thing in a root, it makes 1 out of the root. I tell my algebra students, roots are a 2-for-1 deal. I think I might have said that, right? 2 for 1. 2 10s in a root, 1 10 out of a root. Plain 10. Because it's the root of 100, which is plain 10, right? And then 6 times 10 is 60. So there's the cosecant, and it is negative, just like sine was. Let's do cosine, flip cosine. You got secant. Flip it upside down. Instead of negative 1/19, it's negative 19 over 1, which is just negative 19. That was easy. Well, actually, they gave me that in the beginning, didn't they? Right here, yeah. Better have that one right. Secant is negative 19. And then finally, cotan. Just flip this, so it's 1 over 6 root 10. It is positive, because this one's positive. Just flip it. Same deal. Can't have a root on the bottom. You know the deal. Multiply top and bottom by root 10. And then what do you get? You get root 10 on the top. The bottom, 60 again. Because root 10 is plain 10 times 6, 60. And that's positive. And there we go. We got all 6 trig functions. Questions I can answer on that? Yeah. The hypotenuse cannot be. Yeah, you're right. So if you wanted to be deal with the signs all the way through, which is what I was always trying to show my daughters, but they weren't interested. We fix it at the end, Dad. But yeah, you're right. If you want to be more careful, sine ways all the way through. You're exactly right. So this is 19. This is, the hypotenuse is always positive because it's a distance, right? Whereas these are just back one, so that's negative, down, so that's also negative. So this is negative, what was it, 6 root 10? 6 root 10. Yeah, those two are both negative. That's why the different things happen with sine, cosine, and tangent. Yeah. But you don't have to mess with that. If you want to, if you'd rather, because it is easy to overlook that and accidentally do that wrong. So I would check in the end with the all students take calculus thing and make sure you have the signs right. Right? We're in the third quadrant, which means tangent and his upside down, cotan, are the only two that are positive. That's what this all students take calculus thing is telling you. Which two are positive? Or in the first quadrant, all 6 are positive. Right? So when it says T in the third quadrant, I mean tangent and his upside down, cotan, are the only ones positive. The other 4 are negative. So sure enough, tangent should be positive and his upside down, cotan, the other 4 are all negative. So you can just do it that way. Questions? Other questions on that one? We good? So let's do that. Okay. So they're giving me 224 degrees. Do you know which quadrant that's in? Quadrant 3. We good? Because this is 0 degrees, 90, 180, 270. Just keep adding 90, right? So if you're turning through now, you start here at 0, and then 90, 180, all the way down to 270. So 224, I don't know, it's somewhere right around here. It's like, and you always start here at 0, right? So from 0 to there, that's 224 degrees. Looks something like that. Somewhere in the third quadrant. I'm not being real exact. Okay. Please make sure, if I can hear voices up here, make sure you just, great to help each other, just whisper so everyone around you is not distracted, please. Thank you. 224. So how do we, now what they want from us is the reference angle. What is a reference angle? I mean, what is it physically?
It hits the x-axis.
Hits the x-axis. Are we good with that? It's this one, right? That's the reference angle. That's what they mean by reference angle. It's an angle you're going to refer to. It's a reference angle, and it's always to the x-axis, not to the y. Now it's time to tell you why. Why? Why do we do the x-axis and not the y? Well, because what we're trying to do with a reference angle is we'd like to find an angle that we can use that's less than 90. We don't want to use 224. It's kind of cumbersome to deal with. It's a big old number. We'd rather just deal with a tiny number that's between 0 and 90. So in other words, what we say is just find the little angle right there that just goes to the x-axis. Rather than using the whole 224, just use this little angle. And what? And you'll have the same sine, cosine, tangent, etc. In other words, they're gonna ask me, well, like what they just did ask me in the last problem. They asked me to find all the trig functions in that. In fact, we were even in the third quadrant, right? We were in the third quadrant, and I found all 6 trig functions in that third quadrant. Well, the deal is, I did it. If you look back, I did it by finding this angle, which technically is a reference angle. right? Because the real angle, even on this one, the real angle is from the here. This is where you start all the way to there. That's the real theta. You have to start at the positive x-axis. So the real theta is from here all the way to there. That's the real theta. But I just went here and said, I'm just going to say theta is really just this one to the x-axis. That's a reference angle. Technically, really, that's not really theta. Theta is really the whole thing. But it's all going to come out the same. Sine, cosine, tangent, and the other three, they're all going to come out the same. Why? Because the original angle is from the x-axis, and the reference angle is also from the x-axis. That's why we got to do it from the x-axis, not the y. One more time. Why? Because where do we start? Where's 0? X-axis, not y. So in other words, if you're doing some kind of angle to the x-axis, you're doing the same thing as the whole angle. So let's figure this one out, and then I'll get more specific. So what is this opening here? If this is 224 all the way to there, how much further than 180 is that? Just subtract them, right? 224 minus 180. That's what? 44? So this must be 44 degrees. Are you with me? Because it's 180. It's 180 plus 44 more to be 224. So the reference angle is 44 degrees. Meaning, if you just find the sine, cosine, tangent, and all the rest for 44 degrees, that's going to be the same as the whole 224. Because the 224 goes all the way to there. It's really just 44 degrees off of the x-axis. So it's the same angle with reference to the x-axis. It's the same distance from the x-axis. That's all that matters in the end for sine, cosine, tangent, and all the rest. That's why we do x-axis. Is that good? So they're asking us for reference angle. Reference, let me write it clear. Reference angle means from the x-axis. That's what it means. From the x-axis. Why? Because the original start is from the x-axis, not the y. They could have made this whole thing different. They could have said, hey, we're going to make straight up 0 degrees, the y-axis, you know. They could have made it that way. Straight up is 0 degrees, that's the y-axis, and we're always starting from there. So when we say 224, we mean 224 from there, and then we would have done all reference angles off the y-axis, because whatever off the original 0 would have been the same as how far you are from the y-axis. They could have done it that way. They just did it. There's just how they did things, like driving on the right side of the road. It's just what we do in North America, right? There's not any other deeper reason, right? So there it is. So they just made 0 degrees be the positive x-axis. They made it the x-axis. So any angle then is going to be off the x-axis to have the same trig function values. That's the reference angle. Let's try that. So 9 pi over 5, and they want me to find the reference. Reference always means from the x-axis. So what are we going to do? If you could convert it to degrees and then back, might be the easiest thing to do. So I'll do, rather than just working in radians, which I know is hard for a lot of people, a little bit hard for me too. So just plug in 180 there. So 9 times 180 over 5. You know how to convert to degrees, right? Just pop a 180 in for pi, right? And then hit the buttons on your calculator. 36, 81, 324. Something like that. Is that what it is? Okay. 324 degrees. We good? Converted that to degrees. Just use your calculator, 324. So now let me let you go from there. So go ahead, find it now, and then find the reference angle. So first off, find where 324 is. Put it in the correct quadrant. Find out which quadrant it's in. And then find the angle to the nearest x-axis. That'll be the reference angle. And then convert it back to radians. So this is 0. So we good? So 324, which quadrant's it in? Fourth, right? Right over here in the fourth quadrant. So starting from 0, 324 degrees. They call this maybe some words would help, the initial side of the angle and the ending or terminal side of the angle. That's some of the verbiage they use. So you have the initial side of the angle, and then it rotates all the way around to the terminal side, 324. So it'd be like if I turned, if I was facing this way, and I said, I'm going to turn 340 degrees, 24 degrees. So they turn 324 degrees. Now our job is to come in and say, okay, I want to find this angle because this is the reference angle to the x-axis, right? Because whatever the trig functions are for the x-axis, it's going to be the same as the original angle. So, what are all the trig functions there? So, I'm sorry, what is that reference angle? So, how do we find that? How do we find this reference angle? Yeah, does everybody see that? Because from here all the way to there is 360, isn't it? So 360, take away 324, what is that? 36? 36 degrees is the reference angle. Oh, we got to change it back to radians, don't we? So 36 degrees, now we got to go back to radians. Everybody good so far on that? See how I found that? 360 all the way around, and then subtract the 324. We get the reference angle 36 degrees, and then take 36 degrees and multiply. Remember how to convert? Pi over 180, right? Because you want degrees to cancel, so you put degrees in the bottom like that. Everybody see that? That way degrees cancel. And you get 36 pi over 180. Reduce that fraction. Divide by 6, leaves a 6 and a 30. Oh, it actually goes in there. Is it just pi over 5? Nice. Just really clean. The 6 goes into 35 times. So pi over 5. There it is. There's the reference angle in radians. Is that good? I really want you to feel the truth of this. So is it okay with that? I'm going to scribble a little bit more up there. So let me show you one more time why we're into reference angles and why they produce the same trig functions. So here's the 324, the initial side, the terminal side, 324. We're saying that if you just use 36 degrees to find all your trig functions, it's going to be the same trig function. In other words, the sine of 36 degrees will be the same as the sine of 324, that they're going to be the same. And same for cosine, tangent, except for sines. Positive, negative is what I mean by that, right? Other than positive negativeness, which we can figure out based on which quadrant we're in, other than that, the numbers will be exactly the same for all 6 trig functions if you do 36 degrees or you do 324 degrees. They're going to be exactly the same numbers. You can try if you have your calculator. Hit the sine of 36, hit the sine of 324. I don't even have any idea what it is, but whatever it is, they're the same. Other than positive negativeness. Now, why? Why are they the same? Well, because it's the same triangle, you see? 324 degrees ends you right here, right? Which is a triangle right there with an angle of 36 degrees. That's what it is. It's a triangle with an angle of 36 degrees. So the sine and the cosine and the tangent, all the rest are going to be the same. It's the same triangle, just in a different quadrant. Yeah?
The reference angle will always be on the x-axis.
Always on the x-axis, yeah. So why we're into reference angles is because they're easier to deal with and they give us all the same answers for the 6 trig functions. All right, I probably beat that horse enough. You got it. Okay, so this one's negative. Now they're going negative. Negative 125, find reference. And reference always means between 0 and 90 positive. We don't want negative because, again, we're just trying to make things easy. That's the whole point of a reference angle, is we want an easy angle to. We don't want some weird negative thing or something, big number. We just want a nice little number between 0 and 90. That's what you always want with a reference angle, and it also means to the x-axis. as we've said. So try that out. So draw your axis system. Put negative 125. Find out where negative 125 is. And then go to the nearest x-axis. And find your reference angle. Positive number between 0 and 90. So here's 0. Negative 125, which way are we going? Down, down, down. This would be negative 90, negative 180, right? So where's negative 125? It's down somewhere around here. You with me? Somewhere in the, what is that, third quadrant? See how I got that? Because this is 90, and this is more than 90. 125 is more than 90, right? So where's the reference angle? It's to the nearest x-axis. It's right here. This is the reference. However big that opening is right there is the reference angle, because that's to the x-axis, right? So how do I find that? What are we going to do? Yeah, I like that. Yeah, because we know all the way to here is 180. Now, you know, well, what's negative? Whatever. You don't need to worry about negatives and positives. You know that's a 180 degree swing, right? 180, take away 125, right? Take away this part, and you'll get the leftover. What is that, 55? Reference angle must be 55? Is that good? Does that make sense on that? And why we're into that, because that's easier to find all the trig function values, and they'll be the same. It's the same triangle, just in a different quadrant. So really, what this means is we never need to deal with big angles or negative angles. We can always turn them into something between 0 and 90 and find all the trig functions that way with reference angles. That's what we do. We always just turn it into something between 0 and 90 for finding our 6 trig function values, sine, cosine, tangent, and the rest. Questions on that one? Good. Okay, so they're saying angle 3.4. Angle is 3.4. Round and there's hundredths. Okay, that's a little tricky. It's going to be a little tricky. So, 3.4. Let me give you a sec. Go ahead and try that one. I know that probably looks weird to you. I want you to try to think about it for 30 seconds before I dive in. Ask yourself this. Is that radians or is that degrees? Don't say it out loud. Give everybody a chance to think about it. That's the first question. We don't get that straight, nothing's going to work. Is that radians or, no, I know it. Yeah, they were too easy. They said it up there. I probably wouldn't say it. How do we know that's radians? They don't need to say it. You should know that's radians. Why? There's no degree symbol. It's that simple. You with me? Everybody hearing me on that? A lot of people think the following wrong thought, which messes them up. They think, well, it's only radians when there's a pi. Not true. I've said it before. Don't forget it. Not true. But there doesn't have to be a pi to be radians. That's not true. What's true is if there's a degree symbol, it's degrees. If there's not, it's not. That's true. Rely upon that. So there's no degree symbol. It's not degrees. It's radians. So that's a radian angle. So what's the first thing we do when we have a radian angle? We convert it. Yeah, good. Convert it. So this is radians, and so we're going to convert it. How do we convert? Let me help you with that. Remember, you always want, when you're converting, this is over 1, huh? Whenever we convert, remember how the units work? How you want the units to cross cancel on things? So I'm going to put radians down below, huh? So radians cancel out. Like that. Is that good? And then I'll put degrees on the top. And you know it's the 180 pi thing, right? So 180 degrees pi radians. Like that? Isn't that good? You see how I know which way to put that pi 180 thing? It's always pi 180 somewhere or the other, huh, when we're doing the conversion. Do you see how I know which way to put that? again, I knew I wanted radians down below because I'm trying to get rid of radians and go into degrees instead. That's how I know to put the radians down below. And pi always goes with radians, huh? And the 180 always goes with degrees. So you guys have your calculator. Oh, I got my, oh, I didn't bring my calculator. What's 3.4 times 180? 612? 612, thank you. 612, and that's degrees now, huh? Because now we're in degrees. We're not in radians. So again, just use that degree symbol. Whenever that degree symbol's there, you know you're in degrees. Whenever it's not, you're not in degrees. And you're in radians. So we're in degrees, 612 degrees. Now go ahead, and that should be a little easier, huh? Can you find that angle? 612. Oh, no, I'm sorry. It's not 612 degrees. I knew something was mad. I kept looking at it going, something's wrong up there. Yeah, no. We forgot to divide by the pi. Yeah, you have to actually put in the pi number here, the 3.14159, blah, 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 blah. Use your pi. I would actually use your pi button because that'll be more accurate. Do you all have that? Excuse me. Excuse me. So in other words, let me be really clear for you here. You have to take 3.14 times 180 divided by pi. Yeah, so anything in the top needs to be multiplied, and anything in the bottom needs to be divided. Yeah, so 3.4 times 180 divided by pi, because pi is in the bottom. And hit the equals, and you should get something just a little over 180, like 190, 200, something like that. 194.8. How about give me a couple more? 805. 6503. Okay. And that is in fact degrees now. Are we good to there? Is that coming out okay? Does that make sense? How we did that conversion? So I took the original angle 3.14. I knew it was radians because there was no degree symbol. And then just multiply by 180 over pi to get rid of radians. Go to degrees. Hit the buttons on your calculator. Use the pi button because you want. Why am I saying it's a big deal? Well, because they want me to round nearest hundredths. So you need. They want the final answer to be two places. So we need to use more accuracy than that along the way. You know what I mean? And then at the end we'll round down to 2. But if you round real abruptly in the middle of the problem, it'll throw off your final answer. Am I making any sense? You never want to round very much in the middle of a problem. Rounding at the end is fine when they ask you to do that. But in the middle, try to use as many digits as you can so it doesn't throw off the final answer. So I'm using a whole bunch of digits. We good to there? Now, can we now go ahead and let's find out what quadrant that's in? You find that it's a little more than 180, huh? So here's 0, here's 90, here's 180. So it's a little more than 180. It's maybe just about like right there. That'd be the 194, whatever, 194 degrees. A little more than 180, quadrant 3. So we need to find the reference angle. So the reference angle is the one right here to the x-axis. So what do I do to turn this into a reference angle? Minus 180. Is everybody okay with that? Right, you subtract 180 to find out how far it is from the 180. What's that going to be? 14 point the 805 6503 degrees. And last step, now turn it back into radians. A lot of work on this one, huh, when you do the radians on that. Yeah?
Wouldn't it have been simpler to just keep it as radians all the way around?
Totally. Yeah, and I can show that. I'm afraid a lot of people aren't comfortable with that. But yeah, I'll show that too. You're totally right. If you're comfortable with that, way better. Yeah. Yeah, so let's finish this up and then I'll show that too. So everybody good to hear we have the degrees. And now take those degrees and let me take that and bring it over here. 14, what is it? 805, 6503 degrees. And multiply. We've got to convert back now to radians. They want the answer in radians. So remember again, how you know how to do it's going to be the pi 180 thing one way or the other, right? And whenever you do conversion, how do you know which way though? Well, it's cross-canceling units. This is always over 1, and so you want to get rid of what? Get rid of degrees. So I put the degrees at the bottom, so that's not 360. That's where the 180 degrees will go, and the pi radians on the top. See how I knew that? Because I want degrees to cross-cancel. So now take your calculator, take 14.8056503 times pi divided by 180. Anything under the bar is divided, right? So the 14.8056503 times pi divided by 180. And you probably don't need all those decimals. That's probably overkill. You could probably just use 3 of them or whatever. And what do we get? Anybody got an answer on that? 0.258. Other people get that? Yeah? Okay, and they wanted me to round, okay, 100. 100 has 2 zeros, so they want me to round 2 places. They want me to round here, so look 1 to the right, so we'll say 0.26. 0.26 is the final answer. Rounded to the hundredths, right? 100, 2 zeros, 2 places. Remember, you just circle the place you're gonna end at. Look 1 to the right. If it's 5 or more, you go up. Right? 0.26. We good there? That was a lot of work. Because of all the converting, huh? Radians into degrees, and then back to radians in the end. So 2 conversions on that. Questions I can answer on that one?
So how do you do it if you left?
Yeah, so I'm going to show that. If you're okay with that one, let me show you how you would do it straight. Yeah, how you would do it straight is you would just say, okay, look, I don't want to do all that converting. Can I just work within the Radian system? You totally can. If you're comfortable with that. So 3.4 radians. One good thing to do, first off, is you got to know what quadrant that's at. So do you look at 3.4 and have any feel for what quadrant that is in the Radian system? Let me help you gain a feel if it doesn't seem right. You know this is 0, let me write degrees first. 0 degrees, 90 degrees, 180, 270, right? That's degrees. Now think about, what is pi radians again? How many degrees? 180, that's our main conversion point, just always remembering pi radians is 180 degrees. What is pi? What number is actually pi? Well, 3.14, you know that, huh? So 3.14 radians is 180. So this right here is 3.14 radians, 180, yes. So halfway, to go from here to here, you've gone 3.14 radians, 180 degrees, 3.14 radians, right? So what do they have for me? 3.4, that's just a little more, isn't it? A little more than 3.14. So that would make me go, oh, I see. So it's some angle right there in the third quadrant, because 3.4 is a little more than 3.14. So you got to realize all that. So far, so good? This is how you just stay within the radian system. So you go, okay, 3.4. Let me make this a little cleaner. So this is all scribbly. So again, right to there, this is 3.4. It's a little more than 3.14 or pi, right? Okay, so what? Well, then how do you find this right here, which is our reference angle? Well, it's going to be the 3.4 subtract pi, huh? It's going to be 3.4 subtract pi, isn't it? So everybody see that? Just staying in the radian system, because this angle is pi. Right from here to here is pi. So 3.14 subtract pi is the difference, the reference angle. So you guys have your calculator? 3.4 subtract pi, it had better come out 0.26. In fact, it does, yeah. 3.14, that's 0.26, that's right. So that's how you would just stay right within the radian system. You got to realize that pi, pi is 180. Yeah, well, 3.14 radians is 180 degrees. So your option, either way you want to do it, same answer in the end. Less converting here. I mean, no converting. So that's kind of nice. Good? We good with that? All right. Let me see. I just live in a dream world about time. All right. 49 pi over. Let me do one more with you, just staying in the radian thing. Now you could convert it. You could totally do we did one converting a minute ago, right? Just plug in the 180 degrees, do the whole thing. We're fine. Let me just work within radians for one more minute, because that would be easier if you could get comfortable with that. Or you could double check your work that way too. I don't know, there'll be time for that on the test. But anyway, so how would you work within the radian system? Well, the first thing you would need to do is simplify that. Yeah, it's not going to be easy. Yeah, you first off is you gotta realize where that is. That's a bunch of 2 pi's. That's more than a full circle, because it's more than 2 pi. Yeah, you gotta see, this isn't going to be easy. You gotta subtract a bunch of 12 pi's over 6. Why? Where am I coming up with that? Because that's 2 pi. You see, this is 2 pi with a common denominator. So yes, it's kind of tricky. You got to be a little tricky to do that. You got to subtract a bunch of full circles. You got to get rid of however many full circles you can. You just keep subtracting 12 pi over 6, 12 pi over 6. You do 4 of those, and you get down, that's 48, you get down to 1 pi over 6. That's the answer. We're done. So if you realize all that and you're comfortable, I just took a bunch of 2 pi's away. Yeah, you don't have to do that. I mean, I don't want you to try something. You don't try something you're not 100% comfortable with. If you're not sure what just happened, then just convert to degrees and just do it that way. It'll be fine. But yeah, I just subtracted some 2 pi's, which is a full circle, right? I just subtracted some 360s, is what I did. And then it came down to be a nice, easy angle. That is a reference angle. That's an angle. What is that in degrees? What's pi over 6 in degrees? That's 30, because it's 180 over 6, right? That's 30 degrees. That's between 0 and 90. That's it. All right. Well, I don't got time. Come see me. I'll be with you. Okay, so here we go. Here's number 20. They're asking me on number 20, they're asking me for the secant of 1140 degrees. All right, so how do we, see how it says up here, guys? Do not use a calculator. The practice, you'll see on Monday, the practice exam I give you, the first, I think it's 9 questions, will be, it's in 2 parts. So I'll hand you part 1, practice exam, part 1, just like the real exam. It'll be 9 questions, no calculator at all. It's just like that. Do not use it. You'll have no calculator at all. And you do those 9 questions, bubble in your answers for those 9, and then I'll say, when you're done with that, I'll just have them up here on the desk. Just come on up, turn in your part 1, get your part 2. And you just grab your part 2, go back to your seat, and that's the other 16 questions, 25 total, when you can use your calculator. Does that make sense? So the ones that says don't use calculator, you really have to know how to do it without a calculator. So make sure you can add, subtract, multiply, and divide good enough, and whatever else you need to do to really do these without a calculator. So that is important. I'm not just trying to torture you. It is important in calculus that you really have a feel. That's the reason I teach calc a lot of times, different semesters. And it's really important in calculus to not just be able to hit the buttons and get answers, but to be able to have a feel, because we do limits. In calculus, we don't just have like sine of 30. We have a limit, which means the sign is moving to a certain spot. And you have to therefore just kind of know you have to have a feel for what sine really does, more than just button pushing. So that's why I'm trying to help you be strong in calculus. So make sure you know these without a calculator. So how do we do this then without a calculator? Well, that's why we do the reference angles. Because, we don't want to deal with 1140. That's a big old crazy angle. We want to get a nice little angle between 0 and 90. Want a reference angle. So our first job, that's why they had us practice all that reference angle stuff. Our first job is to turn that into a reference angle. How do we turn 1140 into a reference angle? What should I do first? Yeah, subtract some 360s out of there, huh? Take out some, it's more than full circle.
1080.
Is that what it is? So I don't know how many times so. Here, let me just do it so everybody can see. I'll just do it slow. Well, I can't do that. Is that what it's 1080?
Yes.
Thank you. And then subtract another one. Oh, was that already a couple of them?
3 full circles.
That's 3 full circles.
Oh, okay. Here, let me just do it one at a time. I mean, you guys are doing great, and if you're good with that, great. I just want to do it slow so everybody can see. So what would it be? What is just subtracting 360 once? Is it like, I don't know, I can't do it. What is it? 780, thank you. 780. And then, so just keep subtracting 360. What's that, 420? And then subtract 360 again, and 60. Good to there, guys, so far? So just keep subtracting 360s, full circles, until you get it down under a full circle. Under 360. So it comes down to 60 degrees. That means 11, what is 1140? 1140 is like a full 360, another 360, a third 360, and then 60 degrees more. So it's the same as just 60 degrees, in other words. Does that make sense so far? Right? 1140 is just 3/360s and 60 degrees more. So it's really just 60 degrees. They're just trying to be fancy. It's just 60 degrees. They're really asking me, I don't know what ses is, secant of 60 degrees. They're asking me for the secant of 60 degrees. That's really what they want. Okay, so how do I find the secant of 60 degrees? Well, we got to make a little triangle there. Got to make a little 60-degree, remember, draw the little reference triangle there. So let me kind of clean up this picture and draw a nice little triangle there. So again, I make the 60-degree angle on the x. Notice it's on the x-axis, right? Not the y. 60 degrees, and I want to find the secant. The secant, I always like to just work with sine, cosine, or tangent. Secant is upside down of which one? Cosine, yeah. You'll have, and you do get your 3x5 card for both parts of the exam. So yeah, you can write everything right on your 3x5 card. You know, you'll have all, even though you won't have a calculator for the first 9, you'll have your 3x5 card. So you can write all this stuff down, and for part 2, you'll have it for the whole thing. So they're really asking me 1 over the cosine of 60 degrees. Okay, now this is where, remember, do you remember? We memorized, or write on your 3x5 card, 30, 60, and 45. Remember small, medium, large? Remember that whole small, medium, large thing? Those you want to put on your 3x5 card. Let me remind you those real quick. In fact, let me keep erasing the picture. But let me remind you that. So from here to here, remember, small, medium, large. We have the 3 numbers, small. We have root 1 over 2, root 2 over 2, and root 3 over 2. Small, medium, large, like ordering a soda or something. And the root 1 over 2, that's really just a half. But I'm just trying to show you the pattern. That's what this is for sure what you want to put on your 3x5 card. So you can use this in part 1 when you don't have your calculator. This is how you'll do that. Small, medium, and large, root 1, root 2, root 3. Like a pattern. So then you go, okay, where's 60 degrees? This is, remember, this is 30, because this is 90 straight up. So 30, 45, that's halfway to 90, right? And 60. So 60 is right here. So, okay, so what does that mean about the triangle? That means it's over a small amount up, it's over a small up large, isn't it? For 60. Are you tracking with me there? Right, that's only over a little bit, isn't it? And that's up a lot. Whereas if it was 45 in the middle, that would be medium, medium, wouldn't it? And if it was the 30, that would be over a large amount, only up a small, huh? And that's what we mean by small, medium, large, those numbers. So we go, okay, cosine is 60. Now, here's I guess the one other fact you need to know. Cosine is always what? X or Y? X. Cosine is always X. Sine is always Y. So over is cosine. Up is always sine. So over cosine, over the small amount, what's the small number here? A half. So this is 1 over a half. Right, the cosine on the bottom is a half. You with me? And then you just flip that up there. Just whoosh. So it becomes 1 times 2 over 1. In other words, 2. Is that okay, that last trick? Whenever you have a fraction on the bottom of a fraction, it just flips up like a high diver going backwards, flipping out of the water. Right? If you watch the Olympics and the high divers jump in the water, if you ran your DVD backwards and high diver flipped out of the water, that's kind of like what we're doing there. That 2 over 1 flips back up to the top. Is that making sense? Why? Why does that happen? Because this really means 1 divided by a half, doesn't it? Right? 1 over a half means 1 divided by a half. And what do you do with division? You flip the 1 on the right and change to multiplication, remember? That's all I'm doing. just doing that shortcut. I'm just saying divide means flip the one on the right. So just grab, he's really the one on the right. The bottom is the right. Just flip him up. 1 times 2 over 1, 2. Good? Yeah.
Where did you get the 1/2?
Yeah, I got the 1/2 because I did it was 60 degrees. Good question. So 60 degrees is, 30, 45, 60. These are the 3 we memorized, right? Nothing else. I'm not going to ask on the on the first 9 where you don't have a calculator. I'm not going to ask you for the cosine of 38 degrees or something. You can't do that without a calculator. I'm just going to ask you 30, 45, and 60. Or maybe 0 or 90. Just those clean ones, nothing in between. So I did 60. It's over a small amount, up just looking at the picture, right? It's over only a little bit, up a lot. And that's the small, medium, large, which you want to write in your 3x5 card or memorize. So cosine is over, sine is up. So over a small amount, grab the small number, that's the half. Because I knew it was small on that. If they'd asked me, hey, what's the cosine of 45? I went, 45 is here. That's over medium, up medium, right? He's right in the middle. And medium would have been this one. I would have said that's root 2 over 2. If they'd asked me for this one, 30, I would have went, that's over a large amount up a small, and cosine is how far you are over. That's over large. I would have grabbed that one. Would have been root 3 over 2. Everybody seeing what I'm talking about there? Is that good? Questions on that one? Okay. Okay, so cosine 15 pi over 4. Again, this is no calculator, so we got to be able to do this without a calculator. 15 pi over 4. So that means we got to probably, I assume you're going to want to convert that to degrees, right? So you're going to have to convert that. So you're going to have to be able to convert that to degrees without a calculator. A little bit of adding, subtracting, multiplying, dividing. It's a little messy. What's that? Pi over 4? Yeah, it's not going to be pi over 4. Yeah, it's going to be 3 pi over 4. But anyway, yeah, I think it's probably easier just to go to degrees. So I'll just go to degrees with you. So let's take that 15 pi over 4 and convert it to degrees. Good so far. That pi, I just put in 180 in the place of that pi. Now you're going to have to be able to do this by hand, right? You'll have this will be on the non-calculator part. Can you do all this by hand? It's a little tedious, right? I would probably do the dividing first. That would be easier because dividing makes numbers smaller. So I would go 4 goes into 180. How many times? Well, take 180. Dividing by 4 means well, you can just go like this. 4 goes into 180. 4 times be 16, subtract, what's that, 20. 4 goes into 25 times. So it's 45. Or you could have just take 180, cut it in half, 90, cut it in half again, 45. Either way. 45, so this is 45 degrees, and then I got to go 15 times 45. You with me? So now it's 15 times 45. Might be a while since you've done this multiplying by hand stuff. 5 times 5 is 25. 4 times 5 is 20. 22, add a 0. Right, remember all this? 1 times 5, 1 times 4, 675 degrees. So that's 675 degrees. I just converted 15 pi over 4 to degrees. Everybody see how I did it? I just put in the place of pi 180, and I divided 4 into 180 45 times. 15 times 45, 675 degrees. Okay, so now we've got this angle is 675 degrees. So they're asking me for the cosine of 675 degrees. What do I do with that angle right away? Start subtracting 360s, huh? Because that's more than a full circle. So take 675, subtract 360, what's that leave? 315. 315. Oh, yeah, I said it was 3 pi. I was wrong. It's 7 pi over 4. Anyway, whatever. 315 degrees. We good to there? 315. Can I erase some of this? You guys okay? Copy down. So now we got to find. Can you do that? Let me give you a minute. Yeah, better for me to step out here for a second. So go ahead. Find. Now we got down to an angle that's doable. So find. Go ahead and draw your axis system now. Find 315. Find what quadrant it's in, and find the reference angle. And then see if you can find the cosine of that angle. Feel free to compare with those around you if you want. So 315, starting from here, 315 is almost to 360, huh? Right? Now we got to find this reference angle in here. So what's the reference angle? Yeah, good. 360 minus 315. The reference angle's 45. So really, when all is said and done, they're asking me for a 45-degree angle down there, huh? So that's really what's happening. So let me encourage you, just draw right there. This is 45 degrees in that quadrant. We're going to have to remember the signs. All students take calculus. Well, let's put that off to the end, though. Let's just focus on the 45. So 45. Is that small, medium, or large? It's medium, right? So remember the small, medium, large thing. That's what you'll have on your 3x5 card, right? It's a root 1 over 2, root 2 over 2, and root 3 over 2. See the nice, easy pattern? Root 1, root 2, root 3, all over 2. That's the small, medium, large values. Those go for the 30, 45, 60. All right? And we're talking medium, so we're talking about this one. So, and for this triangle, that means it's over medium, down medium. It's over root 2 over 2, down. If you want to put the signs on there, you can just do the signs this way. It's over, positive, down, negative. What is cosine? Always how far over you are. Cosine is always x. It's always your x movement. Sine is always your y. Does that make sense? Cosine is always over. Sine is always up, down. Everybody getting that? That's real important. Cosine is always how far over you go. So if they asked me the sine of this angle, it'd be negative root 2 over 2. It'd be down. If they asked me the cosine, it's over root 2 over 2. It's positive. And sure enough, that also fits with the all students take calculus. Cosine is positive in this quadrant. The other four, and his upside down, are positive. The other four are negative, like sine. True. See? Over, down. That's why. So, the cosine, positive root 2 over 2. Is that okay on that? A lot of work there. We had to convert the angle to degrees, then subtract the 360s, get the reference, and then find it. And it's always going to end up being, if you're doing one of these on the test or the practice test, and you get it all done, and you get some angle that's not one of the nice ones, 30, 45, 60, or 0 or 90, something nice and easy, like you get 28 or something, you messed up, because I'm not going to give you anything but the nice ones on the non-calculator part, right? So you'll know, oh, I must have added wrong. Go back and check your work, find it. It's got to come out 30 or 45 or 60 or 0 or 90 in the end. On the non-calculator part, on the first 9 questions, right? Those are the only ones we can do without our calculator, are the nice ones. One of these exact type I'm going to do. Let's do this. Let's begin with tan 750. Again, no calculator, so give it a try. So you can do it by hand with no calculator. Tan 750. You know the first thing, you got to subtract some 360s. So subtract 360, which get like 390. Subtract 360 again. Get 30. That's a 30-degree angle. We good? So they're really asking you for tangent of 30, aren't they? This is 2 full circles and then 30 degrees. So they're really saying what's tangent of 30? So draw your triangle. Put 30 degrees. It's one of our that's one of the ones we can do without a calculator. So put 30 degrees in there. Small medium, so there's 30. Right there. So over and up, right? You draw a triangle. Over the large amount, up the small amount, huh? Everybody seeing what I'm saying? Right, it's over a lot, only up a little, huh? Up a small amount. And again, notice that the large and the small always go together, and the medium goes with himself, medium with medium. Right, so if you're in the middle, 45, that's half a 90, that's middle, medium, medium, over medium, up medium. But the other two dots, 30 and 60, they're large, small, or small, large, aren't they? They go together. So large, so again, it's root 1 over 2, root 2 over 2, root 3 over 2, small, medium, large. So large, this is root 3 over 2. I'm scribbling here. This is root 3 over 2, and this is small. Okay. And what is now tangent? Tangent, what's the definition of tangent? Sine over cosine, huh? So you want to have that in your 3x5 card. Tangent is sine over cosine. This is sine. Remember, sine is always y. Cosine is always x. Cosine is always over. Sine is always up. So for any dot, how far over to that dot is cosine? Are you with me? Cosine is the x coordinate. Right? So anytime you're at a dot, how far over you are is cosine, how far up you are is sine. X is cosine, y is sine. We good with that? That's real important. So sine is how far over, a half. Sine is how far up, a half. Cosine is how far over, root 3 over 2. Tangent, sine over cosine. And what do we do when we have a fraction over a fraction? We run our DVD backwards, and the high diver flips back out of the water like a fish. Up he comes, right? So it's going to be a half times 2 over root 3. Everybody with me? 2's cancel. It's 1 over root 3. Except we can't leave roots in the bottom. So let's get rid of that. Multiply top and bottom by root 3. So it's root 3. Bottom of root 9 or plane, root 9 or plane 3. There we go. Is that okay on that? Questions I can answer on that? Am I making sense for you? So again, I took the 750, subtracted the full circles, got down to 30 degrees. Drew the triangle. So you guys getting these these are super important, these triangles. This is what I pull out for calculus students all the time. I always do. Draw the triangle on the unit circle, where this is called the unit circle. So here's the triangle, how far over, how far up. I'm doing that all the time with my calculus students, right? So you want to know this really well. This is just almost the most important thing we'll do this semester is these little triangles, small, medium, large. We'll use this all semester long. You'll use it in calculus 1, 2, 3, and beyond. Really, and pre-calc as well. Reviews it. So is that making sense? 30 degrees, 30, 45, 60. 30 is that one. Over is cosine, up is sine. Large, small. Small, medium, large is right up there. Is that good? So tangent is sine over cosine. Sine is how far up, cosine is how far over. There we go. Questions? So get this straight. If this is not making good sense to you, go to see a tutor. Roberto's hours are back there. Come see me. I'd be glad to help. Go over this YouTube, play it again and again and again, working these problems out until that's what I had to do, And I had to spend hours and hours and hours, and I have to look at my notes and read. There wasn't YouTube in my day. That'd be great. Get to hear the teacher say it again, and I just had to look at my notes and go, wait, how did he do that one? What did he do with the thing? And do it again and again and again until I could do it on my own. So that's what you want to do. You want to keep doing these so you can do these on your own. All right. Sine, cosine, cosine, sine. Right. Okay. Yeah. Yep. What do they want me to do on that problem? Do not use a calculator, right? Write the answer as a single fraction. Do not use a calculator. That looks kind of terrible, doesn't it? There's a certain formula they're hitting upon here. Let me write it out for you. So it's sine of 23 pi over 4 times the cosine of 11 pi over 6 plus the cosine of 23 pi over 4 times the sine of 11 pi over 6. Okay, there's a formula, which I haven't given you yet, for the sine of two angles added together. Let me just call it A plus B or whatever. It's sine A cosine B plus cosine A sine B. So this is something you want to put on your 3x5 card. It's called the sum of angles formula for sine. So what that means is if you're adding up two angles, if you're taking the sine of two angles added, the way it works is the sine of just the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. So when I see this sine, cosine, cosine, sine thing, I think, oh, they're doing that. They're doing the add 'em up thing. That's what they're doing. So I recognize that, and I think, okay. So what they want here is they want me to say, do you all see this now? This is really equal to the sine of those two angles added. 23 pi over 4 plus 11 pi over 6. Does that make sense for the first step? Right? See, it's basically this. You just take this thing and you just turn it around. That's what this is up here. Right? Sine of two angles added, 23 pi over 4, 11 pi over 6, is what? Sine of the first, cosine second, plus cosine first, sine second. See how it's just this formula backwards. Right? This is like this part, and this is like that part. Right? You see that? So I see all of this, and I go, oh, that's the sine of those two angles added. Okay, what now? Now, I got to add those angles. So let me add those angles. So how do you add 23 pi over 4 and 11 pi over 6? All of this, notice, is no calculator. This would be on the no calculator part. Can you add these two with no calculator? What do we got to do to add those two? Common denominator. So you got to multiply top and bottom of this one by 3 to make 12 denominator. Top and bottom of this one by 2, right? So 3 times 23, what's that? 69 pi over 12 plus, what's this? 22 pi over 12, right? And add that up, what's that? 89, 91 pi over 12. I just added those up, 80, 91, yeah, right? If you need to add those up vertically, go ahead, right? 69 and 22. Yeah, just running out of room for all this by hand work. So I added them. I got 91 pi over 12. Good so far. So this is sine of 91 pi over 12 is what that means. Oh, that's ugly, isn't it? Yeah. Gosh. These are ugly without calculator. All right, and I don't got time for all this. Look at the clock. It's just racing on us. All right, let me do this, guys. I mean, that's right, but I think there's an easier way now. Sorry. Backing up. Yeah, that's fine. All that I did was true, but this will be easier. I realize we're going to have to convert to degrees anyway, so we might as well just convert each of them. Rather than do the common denominator and all that stuff, since we've got to go to degrees anyway, probably easier just to convert them both to degrees first and just add them. That way you don't got to do the whole common denominator and the degree conversion. So let's take 23 pi over 4 and convert it to degrees. We got to convert both these to degrees now. So 180 over 4. I'm just going to do this quicker because I don't have time. And of course I can't do it. I don't know. Somebody got a calculator? What is the answer to that one? What is it? 1035, thank you. 1035 degrees. The other one is 11 pi over 6. So put in 180 to that one. Come on. That's 330, right? 330 degrees. So we got 1035 and 330 degrees. So this is the sine of 1035 degrees plus 330 degrees. That's the sine of 1365 degrees. We're almost there. We're getting close. Is that good to there? Y'all see what I did? So I saw this big formula. I said, oh, that's sine of those two angles added. Because I remembered the formula. Or it's on my 3x5 card. Sine of those two angles added. Sine of those two angles added. Take those two angles, convert them both to degrees. Add them up. 1365. So really, all of this is the sine of 1365 degrees. But again, I don't have a calculator, so now I got to erase all this and find out what is the sine of 1365 degrees. So I'm going to do that now. Sine of that. So let's try that. So coming down here. So what's the sine of 1365 degrees? Well, you know what we got to do? Start subtracting 360s, right? So 1005, subtract 360, I don't know, 645. Subtract 360, 285. All right, we're getting better. So it's the sine of 285. They're making these things hard. All right, sine of 285, just tedious, lots and lots of steps. So where's 285 degrees? Well, it's past 270. Right? It's about right there. You with me? Right there. 285 is past 270. Okay, 25 is 15 past 270. So what would be the reference angle? $75 degrees. 75 is not one of our memorized numbers, is it? Oh, I'm sorry, all right, let's try it again. Because then we got 75 and I knew we were in trouble because 75 is not one of our memorized angles. That is a formula we're going to get later, not now. I thought, wow, they're bringing this in now? All right, never mind about that formula. It's coming later. We got plenty to worry about right now. We're not going to get that formula right now. Yeah, I guess it's so weird they set it up like that formula. It's weird. Anyway, I should look more carefully ahead at this. So they just want you to do it piece by piece. There's nothing fancy here but piece by piece. Forget about they totally set it up as the big fancy formula. I don't know why they did that. But they don't want you to do any of that. Just do it. Just find the sine of 23 pi over 4. You know what I mean? Just to put in 180. And we just did that one, right? What was that sine of, what was that angle?
1035.
1035, thank you. 10, just do that one separately. So this is the sine of 1035 And what's that? Subtract a bunch of 360s. 75? Is that right? Subtract 360. Am I doing that right? 315? 9. Right. Yeah, 315. So that's 315. So that's really, so the 23 pi, so wherever you got the 23 pi over 4, that is your 315. That's your 315 degrees. Whenever you got that. And the 11 pi over 6, you should just convert these right away. What did the 11 pi over 6 come out to be? We did it a minute ago, right? What was that one? What is it? One more time. 230?
330.
Was it 330?
Yeah.
Do I have the first one right? Is it 315? Yeah? Okay. So 315 and 330. So just plug those in and do the work. Is that making sense? When they say, so everywhere you've got 23 pi over 4, just put in 315. Everywhere you got 11 pi over 6, just put in 330. You with me? So when they say here, 5, so forget about that big fancy formula I gave you. That's later on in the course. I was surprised they were bringing that in now. So just say, okay, this is sine 23 pi over 4. That's 315. They want sine 315 times cosine of 330 plus cosine of 315 times sine of 330. That's really what they're saying. I just converted those all to degrees. Does that make sense? And then you just figure these out one at a time. Sine 315. How do you do the sine of 315? Anybody got the answer? Not too quick? All right. So you draw the little axis system, right? 315. Is right there. You guys with me? Am I totally losing you now because I did the wild goose chase there? Hang with me. We're on the right track now. 315 is right there, which is what reference angle? This is 45. So when we do our little thing here, it's in the middle. 315 is in the middle, right? Okay, and now where does that mean it is? Over middle, over medium, down medium. What's the medium? Small, medium, large. 1 over, no, try it again. Root 1 over 2, root 2 over 2, root 3 over 2. So the medium is root 2 over 2. So that's root 2 over 2. But is it positive or negative? All students take calculus. Negative. Fourth quadrant, negative. Only cosine and his upside down are positive in the fourth. Sine is negative. Negative times, and on you go. Can I just go dot, dot, dot? So you just got to do that for all of them. It's a long, tedious problem.
So they're going to ask for 4 different answers?
4 of, no, they're multiplied together. So I'm going to get whatever right, so it's going to be minus root 2. I'll just tell you the other answers. Cosine of 330, it's not going to be 60 degrees from there. So it's over a half. So the next one, so this is this, cosine 330 is a half, plus cosine 315, 315 is that same spot, 45, so it's over, so it's root 2 over 2, and then sine of 330 will be, 330 is 60 away, sine is negative, negative root 3 over 2. So it'll be those will be the 4 answers you get, like that. When you do all the little triangle work for all 4 of those, that's sine 315, cosine 330, cosine 315, sine 330. You'll get those 4 answers, and then that's minus root 2 over 4, and then this is also going to be minus because it's negative, right? Positive times negative, root 6 over 4. Put that together, minus root 2 minus root 6 all over 4. Done. That's going to be the answer on that one. You see that? So you just got to find 4 trig angle answers. I'll do that. I'm not going to give you one like that on the test. That's just too messy. There's not one like that. It's to me so weird that they made it like that other formula. It threw me off. Good to there? That's it. I really need to move on. To be honest, throwing weird things here at the end. Don't let them throw you off. See right up here it says F is sine. F is sine. So when they say F, they just mean sine. So they want you to do sine of 7 pi over 6 plus pi over 3 minus F again is sine 7 pi over 6 plus sine of pi over 3. That's what they want you to do. Just plug in all those in. I'm going to go dot, dot, dot. You just got to put in 180 and work it out, work it out, work it out. Just like the last one. So lots and lots of practice on that calculus thing. Okay, so they're saying average rate of change. When they say average rate of change, what they mean is f of x2 minus f of x1 over x2 minus, it's like a slope. Yeah, I should just say it's slope. Average rate of change is a fancy way to say slope. Slope. That's like y2 minus y1 over x2 minus x1. Remember that? Remember the slope formula from algebra? But instead of this is y2. Why is that y2? Because what are y values? Function values. I don't know if you've ever seen it written this way. But y values are function values. That's what they are. So this is effectively y2, and this is y1. F of x2 is y2. F of x1. Now, what's the f? Well, what does it say the f is? Sine. So what they want you to do, in other words, is sine of x2 minus sine of x1 over x2 minus x1. Because that's what f is. And what's x2, x1? This and this. So they want sine of pi over 2 minus sine of pi over 4 over pi over 2 minus pi over 4. You see that? See what I did there? So average rate of change is slope. It's how, slope is how fast a line rises. It's the rate of change of the line. It's the slope of the line. So it's the difference of f values. So it's y values over x values. So it's, the f is sine. So sine of this over sine of that. You can write this on your 3x5 card if you're nervous about remembering all this for the test. And then a sine of that minus sine of. So then I'm going to go dot, dot, dot. Let me do one of them with you real quick though. So then you just compute them. You just work them out and compute them. So what is the sine? Let's just do one of them. What's this part? What's the sine of pi over 2? Yeah, let's put in 180. So it's 180 over 2. It's 90. Yeah, so it's 180 over 2 degrees. So it's the sine of 90. Okay, let's draw that on the unit circle. Where's 90 on the unit circle? Straight up here. This is 90 degrees, isn't it? Now that's kind of weird. That's not really small, medium, or large. True. But there are coordinates there, aren't there? What are the coordinates? Like how far, that's this dot. How far over, how far up to that dot?
0.
Over 0, and it's up 1. I don't know if I've made that clear. This is called the unit circle. Unit means 1. When we say the unit circle, we mean the 1 circle. So this whole thing we're doing with sine, cosine, tangent, all that, let me draw it a little more clear, is finding the values on the unit circle. So it's a whole circle. The radius is 1. It's the unit circle. It's radius 1. So right here at 90 degrees, that's the point over 0 up 1, right? That's the x-coordinate, y-coordinate of 90 degrees. Now, remember, x is always cosine. Y is always sine. So for any dot on the unit circle, that goes for the 30, the 45, the 60, right? Wherever you're at on the unit circle, your x-coordinate is your cosine. Your y-coordinate is your sine. So if you're straight up at 90, you're over 0 up 1, because this is a circle of radius 1. So your sine of 90 degrees would be 1. The answer is 1. So this part is 1. What if they asked me the cosine? They're not. But what if they said, what's the cosine of 90? It'd be 0. It'd be the x-coordinate. Because at that dot, you're over 0, up 1. Your x value, your cosine, would be 0. Your sine would be 1. So now you might wonder, where'd the 1 come from? Well, I don't got time, but those values, the small, medium, large thing I did for you, those are all based on a hypotenuse. Like if you did any of them, say you did like the medium, over, up, medium. If you look at it, when I wrote root 2 over 2, root 2 over 2, 2, if you squared that, you'd get 1. They're all based on a hypotenuse of 1. They're all fitting into the unit circle. So that's what we're doing there. We're fitting them into the unit circle. All right, so you'd have to work on this. This, it turns out to be root 2 over 2. And then you got to subtract the bottoms on that. Whew, these are tough. Okay, so sine of theta is minus a half. So let's go to that unit circle. So it's all based on the unit circle again. Let's go. Oops, I missed. Let's go to the unit circle. And remember, there's 3. Now let's expand our thinking of the unit circle. There's really 3 locations in every quadrant. 3 locations in every quadrant. Small, medium, large is in every quadrant. Right? You with me? This is 30 degrees, 45, 60. What's straight up? 90. Then this is now how do you do the next one? What's next? Add 30 more, huh? It's just the same amount, small, medium, large, into the next one. So 90 add 30. This is 120. Does that make sense? And then now, okay, what's this one in the middle here? Well, it's halfway between 90 and 180. Right? It's 90 add 45, isn't it? It's 45 into the second, so it's going to be 135. And then this one, 180, this is only 30 away, so this is 150. Right? See how you're always 30 from each edge? And then the middle is the middle, 45 away. Right? So both of the edge points are 30 away, and then the middle is halfway. Then you can just keep going. The values just keep going. So then add 30, this is 210. The down here is 270. Back up 30, so this is 240. You with me? And then the middle, this is what? 45 degrees. It's halfway. It's half a 90 from 180. So that's 225. Right? So just keep going here. Now this is 300. This is 330 because it's almost to 3. It's just 30 away from 360, coming back full circle to 0. And this one, halfway, 270, add 45, 315. All right, so we found all the values all the way around the unit circle. All the angles. Again, this is called the unit circle, which means its radius is 1, the radius is 1. It's the unit circle. You can put that on your 3x5 card if you want. Might be a good idea for the exam. So, okay, so what are we going to do with this unit circle thing? We are going to find the values. Now remember, at any dot, the x coordinate is always cosine, the y coordinate is always sine. So this is how we're defining sine and cosine. What is sine? It's the y coordinate as you travel around the unit circle. Like somebody says, what's the sine of 120 degrees? Well, go to 120, go to the dot on the unit circle, find the y coordinate there. That's the sine of 120 degrees. It's the y coordinate. Does that make sense? The cosine is the x coordinate. That's the same definition as SOHCAHTOA. Remember SOHCAHTOA? If you put SOHCAHTOA, we've basically put SOHCAHTOA onto the axis system. That's all we're doing. That's SOHCAHTOA. Okay, so, I don't know if I'm making any sense. Why is that SOHCAHTOA? Let me, well, I just want to explain everything, but we don't have time for everything. So if you put this angle right here, you shouldn't do that. That's the y-axis. Put this angle right here. SOHCAHTOA, if you're talking about this, this is the reference angle. SOHCAHTOA, what is SOHCAHTOA? Opposite over a hypotenuse. The hypotenuse is 1. So what is the opposite? It's the height. It's the y-coordinate. Same thing. Is that too quick? Did you see that? See how SOHCAHTOA, so the sine is opposite over hypotenuse, is the same as saying sine is the y value on the unit circle? Is that too quick? I want you to see we're not just making this up as we go along. Well, we are, but we're being consistent. Yeah, you know, math is made up, right? Math is all made up to describe things that are real in the real world. And then we're consistent with what we make up. So we made up sine is opposite over hypotenuse. That was just made up. They could have called it Joe is opposite over hypotenuse. They just made up sine, and they say in any triangle, in a right triangle, it's going to be the opposite over the hypotenuse. They just made that. And then once they made that, we realized logically, oh, that'll be the same thing as if you make a unit circle and you say sine, make a circle with 1 radius, and you make the sine be the y-coordinate. That'll be the same as opposite over hypotenuse. How so? Well, look right here at this little triangle. Look at this little triangle. If I do opposite, this is opposite right here. What is that opposite? The y height over the hypotenuse, which is 1. So y height over 1, that's y height, isn't it? See how opposite over hypotenuse is the same as y height in a unit circle? So those two definitions are the same. All right, I want you to see they're the same. So anyway, I'm not doing 120. What am I supposed to do here? What do they want me to do? They want me to look at this and say, where is sine negative a half? And they say there's going to be 2 places. 2 places. 2 places in 2 minutes. We're almost there. We almost got it. Where's that going to be? Where's sine negative? Now remember my values? Root 1 over 2, root 2 over 2, root 3 over 2. Small, medium, and large. Small, medium, and large. Which one is this? Yeah, it's the small. Root 1 over 2 is the same as a half. It's negative, but it's small. So they're saying sine of theta is negative the small value. It's negative the small value. So what angle? You tell me, guys. Look up here for a minute. Where, among all those dots, 3 dots in every quadrant, 2 of those dots are down a small amount. Why am I saying down? Negative. And y is up, down. If it was cosine, I'd say over. Cosine is sideways, right? Remember, cosine is sideways. So look at all these dots. Look at all of them, and you tell me which 2 dots would have a small negative y coordinate. Because remember, sine is y. And this is negative, small. Half is the small one. This one right here and this one right here. See those 2 dots? They're both down a small amount. Those are the 2 answers. Those are the 2 spots. Do you see that? Those 2 dots are both down a small amount, aren't they? Those are the 2 angles they want. They want you to say 210 degrees and 315. I don't know if they want them in radians or whatever they want, but those, I think they just want degrees. Those are the 2 answers. Those are the 2 angles where the sine is down a small amount. That make sense? Whew, this was a wild section. We didn't begin the other section. All right, so we just finished 1.3. That'll be due, today's Wednesday, right? That'll be due on Monday at class time, 9 a.m. Have a good day. Got questions? Be glad to answer those.